Hi all, I am Vimal, research scholar doing PhD under the guidance of Professor Sankararaman, Department of Optoelectronics, University of Kerala. I am here before you to discuss about our research paper entitled Fractal Study on Saraswati Supercluster, which is published in the Indian Journal of Physics. One of the important achievements of our country in the field of astronomy during the recent years is the discovery of an extremely large galaxy supercluster called Saraswati in the Stripe 82 region by a group of Indian scientists. Superclusters are large group of galaxy clusters which highlight the large scale structure of the universe. Superclusters are subjected to wide range of studies. The origin and the formation of matter in the universe, distribution of galaxies, presence of dark energy and dark matter, etc. can be studied by analyzing the structure, density, luminosity and time evolution of superclusters. Saraswati supercluster is at a distance of about 100 megaparsec away from the Earth and extends about 200 megaparsec across in moving coordinates. It is a massive supercluster with a calculated mass of about 2 × 10⁻16 solar mass, and its mean position is at a redshift Z is equal to 0.28. Fractal analysis is an important tool to quantitatively study the distribution of galaxies in the universe. Fractals are self-affine or self-similar objects which are irregular and have a scale invariance. The complexity of a fractal pattern can be quantified by using fractal dimension. The distribution of galaxies in the universe can be studied by considering it as a fractal pattern. In the present work, Saraswati supercluster is subjected to fractal analysis, and also an attempt has been made to classify regions of identical complexities. Simple and efficient box counting method is used to find the fractal dimension of Stripe 82 region which contains the Saraswati superclusters. For analyzing the variation of fractal dimension over this region, the region is divided into small grids and the box counting method is applied to each grid. For complexity mapping, a contour surface plot of the region is plotted by taking fractal dimension of each grid as a variable. The contour plot gives information about the regions of identical complexity. From the contour plot, it is observed that the fractal dimension of the grids varies between 0 and 2. The central part, spanning about 200 megaparsec, is found to show a high fractal dimension, indicating a high level of complexity or high density clustering of galaxies. This high fractal dimension area in the contour plot at the center region is the same as the position of the Saraswati supercluster. There are regions with a low fractal dimension where there is the presence of voids. It is observed that while going radially outward from any void, the fractal dimension is increasing, which is an indication of the increase of complexity and greater crowding of galaxies in that region. The fractal dimension of Saraswati supercluster is found to be between 1.75 and 2, which suggests a sheet-like morphology to it. The results of the study reveal that fractal analysis using box counting method can be used as a potential tool for studying the distribution of galaxies in the universe. For more details, please refer our paper and site. Thank you.